Hello, this video is a review of experimental and theoretical probability. We are going to start off by reviewing a few definitions. So an experiment is an activity involving chance. Each repetition or observation of an experiment is a trial, and each possible result is an outcome. The sample space of an experiment is the set of all possible outcomes. So there's a couple picture examples there. One being a spinner. You can see there's 5 different colors you can land on. The middle one is odds when you are flipping a coin with heads and tails. And then the last one is an example of a die where you could roll that and look at the probability associated with it. Definition of probability is a number that tells you how likely an event is to occur. Experimental probability is how the experiment does turn out, like when we're doing an experiment, and theoretical probability is how the experiment should turn out. So when the probabilities of 2 or more outcomes are the exact same, the outcomes are said to be equally likely. Okay, so first example here, we have a spinner. When we're calculating probability, what we do is we take the number of times the event occurs and we divide it by the total number of trials. This is how we figure out the experimental probability. So on our first example, it says after 100 spins of the spinner, the outcomes were recorded below. Estimate the probability of the spinner landing on red. So if we want to figure out the probability, let's see here. The probability of, let's just do an R for red, that would be 24, since it happened 24 times out of 100. So it'd be 24 out of 100, and we could simplify that to, let's say we divide by 4, we could say 6 out of 25. So probability of getting red was every 6 out of 25 times. So I want to give an example here. This is the different ways we can explain probability on this line here. So there are 4 words or phrases we usually use. So the first one is that something is impossible. So if something is impossible, you can see it's down here, the outcome of that is 0. So there's 0 chances of that happening. If an outcome is certain, it's 1, okay, which means it's going to happen. It's guaranteed. Our probability here for the red was 0.24, 24 out of 100. So that's closer to the unlikely side. It's closer to the 0. And then we also use the word likely when it's closer to certain but not certain. Okay, so a couple examples. Says Mr. Larson has been in 5 accidents in 35 years of driving. Find the probability that Mr. Larson will get in an accident this year. Well, if we think back to probability, it's the number of times something happens over the total number of trials. So he got into 5 accidents, and that was in 35 years. And we can divide those both by 5, and the probability is 1 out of 7. So the probability that Mr. Larson will get in an accident this year is 1/7. Part B says to predict the number of accidents you expect Mr. Larson to get into over the next 15 years. So to figure this out, let's set up a proportion. We know the probability of him getting in an accident is 1/7, and we want to figure out over the next 15 years how many he will get into. Oops, so that shouldn't be 1 there, excuse me. We want to figure that out. That should be our x there. So 1/7 is the probability in this first year. So how many in 15 years? Here I'm going to use cross multiplication to solve. So 1 times 15 is 15, and then 7 times x. So we have 15 equals 7x. Divide by 7, and we get x is equal to about 2.14. Example 2 says Alex saves 24 out of 28 shots on goal. Find the probability that Alex saves the next shot on goal. So he saved 24 out of the 28 goals. We can divide both of these by 4, which would give me a probability of 6/7. Okay, so Alex is saving 6 out of every 7 shots on goal. So it says predict how many he is going to save if there were 40 shots on goal. So we know he saves 6 out of every 7, and there are going to be 40 shots on goal. So again, I'm going to use cross multiplication to solve this problem. So do 6 times 40, that gives me 240, and that is equal to 7x again. I'm going to divide by 7, and that gives me about 34.3. So if you wanted to, you could round down to 34 goals that he would save. Okay, so next we're going to look at theoretical probability. Remember, theoretical probability is what should happen. So it's the number of desired outcomes over the total number of possible outcomes. So that little spinner, I know it's kind of hard to see, but it says find the probability of spinning yellow. The probability of spinning yellow is 3/8, which is shown here. That's because there's 3 ways to get yellow. There's 3 yellow spots out of 8 total spots. So the theoretical probability of spinning yellow is 3/8. Okay, for our next examples, it says we're rolling a 6-sided die. Find the theoretical probabilities of, first example says rolling a 5. Well, there's only one side on a die that has a 5 on it. So one way out of 6 possible ways. Probability of not rolling a 5. Well, if I'm not rolling a 5, I can get 1, 2, 3, 4, or 6. That's 5 different ways out of 6 ways total. Probability of rolling an even number. Well, there's a 2, a 4, and a 6 on a die, so that would be 3 out of 6 sides, which is a half. Probability of rolling a 7 is 0. There's no 7s on a die. And probability of rolling a number less than 7. Well, that's every side of a die. It's 1 through 6, so it's 6 out of 6, which is 1. So just a quick review of some vocab words we just introduced. If an outcome is certain to happen, then the probability of that outcome is 1. If it's impossible, then the probability is 0. So the probability of rolling a 7 is impossible, whereas the probability of rolling a number less than 7 is certain. Okay, so moving into a couple more examples. Now we are rolling 2 dice. It says find the theoretical probability of rolling doubles. So that means 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, or 2 6s. And find the probability of rolling a sum of 8. So when we're trying to figure these out, it is helpful to think about the sample space. Or in other words, to think about what are all the possible outcomes for our dice. So I put together this example here. This is the sample space for 2 dice. So it lists all the possible outcomes of what I could get when I'm rolling. So for example, I could roll 2 1s, I could roll a 2 and a 1, a 3 and a 1, a 4 and a 1, a 5 and a 1, and a 6 and a 1. So those are the first 6 options. Or if you keep going through these, you can see these are all the different combinations I can possibly roll with my 2 dice. So in our problem here, we needed to find the probability of rolling doubles. That was our first problem. So if I'm rolling doubles, let's circle those in black. These are all my doubles. Okay, so there were 6 ways to get doubles, and there's 36 possibilities. That's our first problem. And the second one was to roll a sum of 8. So we're looking for combinations that give us a sum of 8 on our dice. So I could do 6 and 2, 5 and 3, 4 and 4, 3 and 5, or 2 and 6. So let's go fill those in on our next slide. So probability of rolling doubles, we said there were 6 ways for that to happen out of 36 ways total, which simplifies to 1/6. And then the probability of rolling a sum of 8, we found 5 options on that previous slide out of the 36 total. So for some of these problems, drawing a sample space or almost like a diagram or picture of the outcomes will be helpful. Okay, next problem says your family has 3 children. Find the probability of there being 3 boys and find the probability of having 2 girls and 1 boy in any order. Okay, we're going to look at some sample spaces again to help us with this problem. This is an example of a tree diagram for two children families. So this is where there's only 2 kids and not 3. We're just going to look at this first. We call it a tree diagram because you can see how it branches off. So with this first child, it can be, you can see a boy or a girl. First child. So if the first child is a girl, the second child still has the option of being a girl or a boy. Same with if it's a boy, it can still be a girl or a boy for the second child. So this column is where we see all of our different outcomes. So we could have a girl and a girl and a boy and a girl, and a boy and a boy. So we want to know what's the probability of having exactly 2 girls. Well, that only happens one time out of these 4 different options. So the probability of having 2 girls is 1/4. What we need to do now is draw a tree diagram for 3 children. So we're going to start at the beginning. For the first child, we can have a boy or a girl. That's child 1. For the second one, again, we can have a boy or a girl, and a boy or a girl. For our third child, same thing. Boy or a girl, boy or a girl, boy or a girl, and boy or a girl. So if we look at our combinations for this top one, right, it would be a boy, and a boy. So let's write that as boy, boy, boy. For our second one, we have boy, girl. So 2 boys and then a girl. For my next one, I have boy, girl, boy. That's my third possible outcome. I could have boy, girl, girl. And then let's switch to our second half. I could have a girl first and then have a boy and a boy. So girl, boy, boy. I could have a girl, a boy, and then a girl. I could have a girl, and a boy. Or I could have a girl, and a girl. So altogether, there are 8 right here. This gives me 8 different outcomes. So there are 8. Okay. In each step here, we have 2 choices in our for the first child, 2 options with our second child, and 2 options with our third child. So when we know how many possible outcomes in each step, we can actually multiply them. So 2 times 2 times 2 gives me 8. That's also another way to get your possible outcomes. So if we go back to our problem here, we had to find the probability of having 3 boys. So we want to look at our possible outcomes in that black box, and then the probability of having 3 boys. Well, there's only 1 out of 8 options. And then our second one was a probability of 2 girls and 1 boy in any order. So I'm looking for next 2 girls and 1 boy. So here's 2 girls and 1 boy, 2 girls and 1 boy, and 2 girls and 1 boy. So in blue, there's 3 options out of 8 total. So let's fill that in here. The probability of having 3 boys was 1 out of 8. And the probability of there being 2 girls and 1 boy in any order was 3 out of 8. All right, the last thing we're going to look at is odds. Odds are a way of expressing a probability as the ratio of the number of things that you are not looking for to the number of things that you are looking for. So the odds against flipping a coin and it coming up heads are 1 to 1 because there are 2 sides of the coin and you are only looking for one of them. Another way to think about it is the ways an outcome can occur to the ways an outcome cannot occur. One example here, there's a little table shown. So a fraction would be that you could have maybe an 1/8 chance of winning. Well, the odds against winning then would be you have 7 ways of not winning to 1 way of winning. Okay, next spot in the table we see like a 1/7 here. So if that's your chances to win, that means there are 6 ways not to win and 1 way to win. So that's the odds against winning, hence why the 6 is on the left and the 1 is on the right. So for example, 1, if we're finding the odds of rolling a 5 on a die, well, there's 1 way for that to occur, and there are 5 ways for it not to occur. Example 2 says find the odds against rolling a 5. So against rolling a 5 would be anything but a 5. There's 5 ways that can happen and 1 way it cannot happen. Find the odds of rolling an even number. Well, there's 3 even numbers on a dice and 3 not even numbers, which is 3 to 3 or 1 to 1. Here are some random odds that we pulled up. So like odds of bowling a 300 game are 11,500 to 1. Odds of getting a hole in 1 are 5,000 to 1. So these are against. So this would be against and then to it happening or for it happening. So you have 11,500 chances against doing it compared to the 1 that you have to having it happen. Odds of winning an Olympic medal, 662,000 to 1. Odds of an American home having at least 1 container of ice cream in the freezer, 9 in 10. Thanks for watching, guys.